Good morning to all of you, and once again welcome back to my channel Steam Mechanical. In this video I will be solve few questions which will be very helpful for you for any kind of competitive exam as well as for your university exam. So let's go to the point of discussion. First of all, carefully read the question. Heat is being transferred convectively from a cylindrical nuclear reactor fuel rod of 50 mm diameter to water at 75 degrees centigrade under steady state condition. The rate of heat generation within the fuel element is 50 into 10 power 6 watt per meter cube, and convective heat transfer coefficient is 1 kilowatt per meter square Kelvin. Okay, the outer surface temperature of the fuel element would be, so basically this is the fuel element. Okay, basically a nuclear rod, and around this nuclear rod there is a water. Okay, water is present. The temperature of the water is also provided to us. It is 75 degree centigrade. So the water temperature is 75 degree centigrade, and we have to find out some here the temperature of the nuclear rod. Okay, means the outer surface temperature of the nuclear rod, something here or here, anywhere at the outer periphery. Okay, so let's try to solve the question. First, here the heat generation is given at watt per meter cube. Basically it is not a heat generation, it is the rate of heat generation. So first of all we have to find out the total heat generation. Let we represent it at a Q suffix G, total heat generation, capital QG. It is the small qg which represent the rate of heat generation into total volume. Okay, now this small qg provide us 50 into 10 power 6 into volume. The rod is cylindrical in shape, so volume is pi r square. R value is 50 mm is diameter is 50 mm, so radius is 25 and it is in millimeter, so we have to convert it in meter, so 10 power minus 3. Okay, pi r square into length. So this is the total heat generation. Now carefully try to understand. Whatever the heat generation is takes place, this total amount of heat generation we have to assuming that is convected to the water. This one is given also. Heat is being transferred convectively. So whatever the heat generation takes place, it is convected to the water. So we required to equate this total amount of heat generation is equal to the total heat convection. Am I right or wrong? This is the basically main point for such kind of question to solve. Carefully, total amount of heat generation, basically this amount of heat, where it goes, it basically transferred to the water. So we can equate the total amount of heat generation is equal to heat which is convect to the water. Okay, so heat generation we are getting 50 into 10 power 6 into pi into 25 into 10 power minus 3 square into L. Now this heat convection, Q convection can be written as a H into surface area into delta T, means temperature difference. Here this H is the convective heat transfer coefficient. They are given 1 kilowatt per meter square Kelvin, but we have to convert it in watt, so multiply by 10 cube into. Now this area is basically not the surface area or not the cross sectional area. You have to remember this area is basically the area through which the heat is transferred. So based on the question, it may be cross sectional area, it may be surface area. So here it is surface area, because throughout the whole surface heat is convected to the water, so we have to here take it surface area. And surface area for a cylinder is 2 into pi into r. R is 25 mm. If I convert it in meter, then 0.025, okay, 2 pi r into L. Now here temperature difference, obviously heat is generated in this nuclear rod, so surface temperature will be more than that this water temperature. So let we assume Ts is the surface temperature here, okay, minus this 75 degree centigrade. Now before put this 75 degree, please take a look to the option. If in the option they are provide the answer in degree centigrade, then put it here in degree centigrade, because this one is the difference in temperature. So whatever you will be put here, this unit will be your answer. So here I put here 75 degree centigrade. So whatever the surface temperature I will be get, it will also be in degree centigrade. So here pi get cancel out, this L get cancel out. If I solve, then I can get surface temperature minus 75 degree centigrade is equal to, and one thing, this 0.025 basically cancel this square one, okay. So with help of calculator, let it solve. 50 into 10 power 6 into 25 into 10 power minus 3, okay. I'm not take the square, because this square is cancelled out by this 0.025, which is nothing but the 25 into 10 power minus 3, okay. So if I multiply it, I'm getting some value divided by this 10 cube, okay. So I'm getting 1250 divided by 2, so 625. So surface temperature is 625 plus 75 plus 75, I'm getting 700 degree centigrade. So basically option A is our answer. So in this question, the point which one you have to understand that whatever the heat generation, this heat is basically convected to water, okay. Heat generation is equal to heat convected to water. So it is clear now. Now solve the next question. So carefully read the question. A gas filled tube has 2 mm inside diameter and 25 cm length. The gas is heated by an electrical wire of diameter 50 microns located along the axis of the tube. Current and voltage drops across the heating element are 0.5 ampere and 4 volt respectively. If the measured wire and inside wall temperature are 175 degree centigrade and 150 degree centigrade respectively, find the thermal conductivity of the gas filling the tube. First thing, here you have to find out the total amount of heat generation. This is your first task. So heat generation, once again if I represent it as a Qg, now here in this question, whatever the heat generation, this one is due to the voltage drop and current drop across the heating element, means the electrical energy converted into heat energy. Now we know heat energy from the electrical energy, how we can find out? Heat energy is equal to V into I, okay. So here V is 4 volt, current is 0.5 ampere, so it's provide us 2 watt. So this 2 watt is the total amount of heat generation. Now carefully listen. Here basically they are said that if we are assuming this one is the tube, okay, this one is the tube and a heating element which is nothing but the wire with 50 microns diameter is basically placed at the along the axis of the tube, and the tube is filled with some kind of gas, okay, and we have to find out the thermal conductivity of this gas only, okay. This one is the wire, this one is the tube, and this is the gas which fill the tube, okay. Now we are get the heat generation. Now you tell me the heat generation is basically conducted to the gas. It is clear or not? Total amount of heat generation due to the voltage and current drop is basically conducted to the gas. Means if we equate this total heat generation is equal to heat conducted, then it is absolutely right. Okay, now heat generation we are get 2 watt, so 2, but heat conducted for a cylinder, heat conducted is 2 pi k of this gas. So I'm here writing k gas, 2 pi k into length into temperature difference. So first of all here temperature difference means the temperature of the wire and the temperature of the inside wall, okay, which is nothing but temperature of the wire minus temperature of the wall, okay, divided by ln of R2 by R1. It is clear. So 2 is we are already find it. 2 pi k of gas is unknown, which one we have to find, but length is provided to us. Length value is how much they are given? They are provide us length is 25 centimeter. Okay, so 25 centimeter, if you put it in meter, it will be provided us as a 0.25, and then temperature difference is 175 minus 150, okay, divided by ln of R2 by R1. Let me write it here. R1 is the radius of wire, okay, and R2 is the radius of tube, or you can say the inner radius of tube. So inner radius of tube is 1 mm, okay, so this 1 mm you can write it as a 0.001 meter, and the wire radius is here 50 microns is the diameter, so 25 microns is the radius, but we required it in meter, so 10 power minus 6, okay. So from here if you calculate, you can find out the k of gas. So let it calculate. So first thing, this 2 and this 2 get cancelled out. First ln of 0.001 divided by 25 into 10 power minus 6, okay, this one goes this side, divided by pi into 0.25 into 25. So we are getting 0.1878, okay, this much watt per meter Kelvin. So basically this one is our answer. So in this question, the main point you have to observe that the heat generation is takes place, this amount of heat generation is basically conducted to the gas, okay. So this concept is not basically important for this question. This such kind of concept is important for throughout the heat transfer subject. The total amount of heat generation is equal to the heat which is convected or conducted to the surround. So I think the concept whatever I want to provide you, this one is clear to you, and in this question this much only. So please, if you think the video is helpful for you, then subscribe my channel and share to your friends and like my videos. Thank you.